Okay, so anytime you have an exam, whether it is a campus exam or a district exam or your STAR exam, you're going to be provided with this reference material sheet. The very first thing I would like you to do is to take everything we've learned about chemistry and put it down on this paper so it can help you solve your questions about chemistry. We're going to start with the subatomic particle chart. We know that we have 3 subatomic particles: protons, electrons, and neutrons. And the easiest way to identify them is their charges and their mass and location. So, the charge of the proton. Protons are positive. Electrons are negative, and neutrons are neutral, meaning that they have no charge. Protons weigh 1 atomic mass unit. Electrons are so little that we say they weigh nothing. And neutrons are 1 atomic mass unit. Protons are in the nucleus. Electrons are in different energy levels surrounding that nucleus in the electron cloud. And neutrons are in the nucleus with those protons. Now that we know our subatomic particles, let's look at how we figure out how many of each one there are in an atom. We use this word ape, A equals P equals E, to let us know that the atomic number is equal to the number of protons, which is equal to the number of electrons. So in this example, we have an atomic number of 14, which means we have 14 protons and 14 electrons. To find the number of neutrons, we're going to need to take our mass number minus that atomic number, and that gives us the number of neutrons. That word man comes in handy there. So ape, man. Mass number, we round it to the nearest whole number. So you get 28 minus the atomic number of 14 gives you 14 neutrons in this atom. After that, we're going to look at reactivity. We know something is reactive. I like to write VE capitalized or bolded or underlined, because we know reactivity because of our valence electrons. So our valence electrons are those outside electrons. They're the electrons in the outermost shell or energy level. If we look at our groups on the periodic table, we know that they go up and down, and the groups help us identify the number of valence electrons in each element. So, if we look at elements in group 1, hydrogen, lithium, sodium, and so on, they all have 1 valence electron. Elements in group 2 have 2 valence electrons. Elements in group 3 have, 13 have 3. Group 14 elements have 4 valence electrons. Group 15 elements have 5 valence electrons. 16 elements have 6 valence electrons. And group 17 elements have 7. And 18 have 8. So 8 is a really special number. If we have 8 valence electrons in our outermost shell, that means we have filled that energy level, and those elements will be inert or non-reactive. All elements in group 18 are inert. They won't react with any of the other elements. These elements have a special name called the noble gases. And that is our group 18 elements. Now let's look at groups 1 and 17. Elements in group 1 and 17 either have 1 valence electron or 7 valence electrons, depending on what group they're in. So, group 1 elements with their 1 valence electron are 1 valence electron away from having a full shell. All they have to do is lose that valence electron. Group 17 elements have 7 valence electrons. They are also only 1 away from having a full shell, so they need to gain 1 electron. Because they're so close, these two groups will hold our most reactive elements. Groups 2 and 16 are both 2 electrons away from having a full shell, so they're still highly reactive. Elements in group 13, 14, and 15, we'll just say they're somewhat reactive. They're not as reactive as elements in group 1, 2, 6, or 7. But they're more reactive than elements in group 18 because group 18 elements won't react with anything. Okay, next we're going to look at the periodic table. We know that our periodic table can be split into 3 sections: metals, nonmetals, and metalloids. This is something we learned in 5th grade. So the easiest way to separate these groups is to go ahead and color those elements on the staircase. Those are our metalloids. Our metalloids have characteristics of both metals and nonmetals. To the right of the metalloids, we have our nonmetals, and to the left, we have all those metals. The other way we can divide our periodic table is into groups and periods. We've talked about how groups go up and down and give us the number of valence electrons, and now we need to look at periods. Periods go side to side, and the period number tells you the number of energy shells that the atoms or the elements in those periods will have surrounding their nucleus. So elements in period 1 will have a nucleus surrounded by 1 energy shell. Period 2 elements will have a nucleus surrounded by 2 energy shells. Period 3 elements will have a nucleus surrounded by 3. Period 4 elements will have a nucleus surrounded by 4. 5 will have 5, 6 will have 6, and 7 will have 7. I do recommend that you draw the energy shells for periods 1, 2, and 3. After that, it gets really hard to fit that many energy shells into that small of a space. So you could just write out 4, 5, 6, and 7. The next thing I want you to do is go up into the top corner and write down this chemical equation. Wow, I'm sorry, I apologize for that. So if you write down this chemical equation and look more closely at it, we're going to work with the reactant side at first. So the first thing I want you to do is draw a rectangle around that large 2 in front of that chemical formula and write that this is the coefficient. That large number in front of that chemical formula tells you, or at the beginning of a chemical formula, tells you the number of molecules present. Next, circle those little 2's beneath the writing. Those are your subscripts. They tell you the number of atoms in 1 molecule. So, if we take our 2 molecules that we have in our reactants and multiply that by our 2 hydrogen atoms that we have in that first part of our reactants, we get that there are 4 hydrogen atoms total. The second to last thing that we're going to do is look at evidence of a chemical reaction. We learned this with that sentence, city girls love their phones, sometimes. Or, city girls love their smartphones. It doesn't matter which sentence you use as long as you get all those letters included. So, C stands for color. When you have an unexpected color change, that can be an evidence of chemical reaction. G stands for gas, or the formation of bubbles can be indicative of a gas being formed. L stands for light, T stands for temperature, P stands for precipitate, and S stands for smell. If we look more closely at temperature, we have 2 ways that this temperature change can occur. Either it can get warmer or it can get colder. When it is warmer and releases heat, we call that an exothermic reaction. When the temperature decreases and it feels colder, we call that an endothermic reaction. The very last thing I want to look at is our law of conservation of mass. The law of conservation of mass says that matter cannot be created or destroyed. So the number of atoms in the reactants must equal the number of atoms in the products. If they are equal, we'll say that the chemical equation is balanced. If they are not equal, we'll say that it is unbalanced. That is all we have for this. So mark up your periodic table and good luck.